It's kind of crazy these days. You can barely have a conversation without AI coming up. Like it's everywhere, generative AI especially. It's amazing. But sometimes I feel like I'm just getting bombarded with information and not really absorbing it. You know what I mean?
Yeah, definitely. I think a lot of people feel that way right now. It's just moving so fast.
Right. So we wanted to pick out a couple of resources that we thought were particularly helpful for getting a good grasp on this whole AI thing.
Absolutely.
So we're looking at the official AWS Certified AI Practitioner exam guide and this really awesome cheat sheet that goes with it.
Hmm.
Now, even if you aren't planning on taking the exam itself, these documents are honestly super valuable for anyone who just wants a solid understanding of the fundamentals.
Yeah, for sure. They lay everything out really nicely.
Yeah. So in this deep dive, we're going to pull out the most important concepts, see how they actually apply in the real world, and we'll even touch on some of the bigger picture stuff like responsible AI, security, and governance, all the things that make you a well-informed, responsible AI user.
Yeah, exactly.
We're going to be talking about all kinds of AI models, from computer vision, which is how computers see and understand images, to recommendation systems, those algorithms that try to figure out what you might be interested in.
Hmm.
And we'll look at the key tools in the AWS world, like SageMaker and Bedrock.
Right.
The goal is to break it all down in a way that makes sense without getting too bogged down in the technical jargon.
For sure.
All right, so let's start with the basics. When we say AI and ML, what are we actually talking about?
Well, at a high level, AI, or artificial intelligence, is all about creating computer systems that can essentially do things that we normally think of as requiring human intelligence. Like reasoning, learning from experience, and making decisions on their own to achieve a specific goal.
Okay.
Now, machine learning, or ML, is a particular approach to achieving AI. And the key here is that with ML, we're creating algorithms that allow computers to learn directly from data without us having to program every single step explicitly. So, for example, if you wanted to teach a computer to recognize cats, instead of writing down all the rules like if it has pointy ears and whiskers, then it's a cat, you would feed it a huge amount of cat pictures, and the ML algorithm would learn to recognize the patterns on its own.
So instead of telling it the rules, it kind of figures out the rules by itself just by looking at tons of examples.
Exactly.
I see.
Yeah.
Okay. And then there's this term that gets thrown around a lot, deep learning. How does that fit in?
So deep learning is a more advanced subset of machine learning. It uses what are called artificial neural networks. These are structures that are inspired by the way the human brain works with interconnected neurons. But in deep learning, these networks have many, many layers, which is where the deep comes from.
Okay.
And these deep neural networks, they're very powerful for analyzing complex patterns in data. This is the technology that's driving a lot of the breakthroughs we're seeing in things like image recognition, natural language processing, and even generating realistic text and images.
Okay, so that leads us to large language models, LLMs, which seem to be all the rage these days. How do those work?
Right. So LLMs are a specific type of deep learning model that's trained on a massive amount of text data.
Mm-hmm.
And they use a special architecture called a transformer architecture, which includes things called encoders and decoders. And importantly, there's this mechanism called self-attention, which is really the key innovation here.
Okay.
Self-attention allows the model to understand the relationship between words, even across really long sentences, something that previous language models struggled with.
Gotcha.
And that's why LLMs can generate such coherent and contextually relevant text. They're not just looking at one word at a time, they're understanding the connections between words in a sequence. This architecture allows them to really grasp the context, and that makes them exceptionally good at tasks like writing different kinds of creative content, summarizing large amounts of information, and answering your questions in a comprehensive way.
Okay, so just to recap, we have AI, the big umbrella term, and then within that we have ML, which uses data to learn. Then deep learning is a more sophisticated type of ML using these deep neural networks.
Mm-hmm.
And then LLMs are a type of deep learning model that are specifically designed for understanding and generating language.
Exactly.
That makes sense.
Yeah.
We also hear terms like NLP, computer vision, and speech recognition thrown around a lot.
Right.
Where do those fit in?
So those are more specific application areas or subfields within AI, and they often rely heavily on machine learning and deep learning techniques. Natural language processing, or NLP, focuses on enabling computers to understand and work with human language. Things like analyzing text, translating languages, and generating text that sounds natural.
Okay.
Computer vision gives computers the ability to see and interpret visual information from images and videos, much like our own visual system. And speech recognition is all about converting spoken language into written text. And all of these areas often use neural networks, particularly deep learning models, as the core engine driving their capabilities.
Okay, that makes sense. So it's like AI is the overall field, and then these are specific areas within AI that use these techniques.
Exactly.
Okay. The exam guide also mentions different ways that these algorithms can learn, like supervised learning, unsupervised learning, and reinforcement learning. What are the differences between those?
Yeah, so those categories describe the type of data and feedback that's used during the learning process.
Hmm.
In supervised learning, the data that we feed to the algorithm is labeled, meaning for each input data point, we also provide the correct output. So going back to that cat example, each image would be labeled as either cat or not cat.
Okay.
And the algorithm learns to associate the features of the image with the correct label.
Gotcha.
Unsupervised learning, on the other hand, deals with data that doesn't have labels.
Okay.
So the algorithm's job is to find patterns or structures in the data on its own. For example, it might group customers into different segments based on their purchasing behavior, even though we haven't told it anything about those segments beforehand.
I see.
Reinforcement learning is a bit different. In this case, you have an agent that learns by interacting with an environment,
Mm-hmm.
and it receives rewards or penalties based on its actions.
Mm-hmm.
So it learns through trial and error to figure out how to get the most rewards, kind of like how a robot might learn to navigate a maze.
Okay. So moving on from the theoretical stuff, where are we actually seeing AI and ML making a real difference out in the world? What are some of the practical use cases?
Well, AI and ML are being used in more and more industries all the time. They're great at helping humans make better decisions by analyzing huge amounts of data. And they allow businesses to scale their operations by automating tasks. It all boils down to efficiency.
Okay.
So think about things like chatbots and virtual assistants, which can handle customer inquiries and provide support 24/7. Another big one is intelligent document processing, or IDP. It uses NLP, deep learning, and computer vision to automatically extract key information from all sorts of business documents like emails, invoices, PDFs, and stuff. So it saves a ton of time on manual data entry.
Right. I imagine IDP would be huge for companies that have to deal with lots of unstructured documents. What are some other
Oh,
examples?
yeah, there's application performance monitoring, or APM. These tools use AI to analyze performance data and predict potential problems in software before they actually happen. Some can even suggest solutions automatically. Oh, that's interesting.
Yeah. In manufacturing, predictive maintenance uses AI to analyze data from sensors to spot signs of potential equipment failures early on, which can save companies a lot of money by preventing downtime.
That makes sense.
We're also seeing major advancements in medical research, like speeding up drug discovery and making medical image analysis more accurate.
Mm-hmm.
And of course, in business analytics, AI and ML help companies spot trends, gain insights from their data, and make smarter decisions. So, yeah, it's pretty versatile.
It sounds like AI and ML can be applied to almost anything. Are there any times when it's not the best solution, though?
That's a good question. It's not a magic bullet for every problem.
Yeah.
Sometimes the cost of developing and deploying an AI solution outweighs the benefits, especially if it's a simple task.
Okay.
And if you need a very specific outcome, something that's always the same, traditional programming might be better.
Okay.
AI and ML are better at making predictions based on patterns and data.
And of course, if you don't have enough good quality data, AI and ML won't be very effective, so it really depends on the problem.
Could you maybe give an example of a problem where someone might be tempted to use AI, but traditional programming would actually be a better choice? And what exactly do we mean by good quality data?
Sure. So imagine you need to automate something very specific, like formatting a report in a particular way. That has clear steps and rules.
Right.
So in that case, writing a traditional script would be quicker, more reliable, and easier to maintain than training an AI for such a straightforward task.
I see.
And when it comes to good quality data, we're talking about data that's accurate, complete, relevant to the problem you're trying to solve,
Hmm.
and free from any major biases or errors.
Hmm.
The better your data, the better your AI model will learn and perform. Garbage in, garbage out, as they say.
Yeah, that makes sense. So the guide also mentions several AWS managed AI and ML services. Can you give us a quick rundown of what those are?
Absolutely. So Amazon SageMaker is like the all-in-one platform for building, training, and deploying ML models on AWS. Okay.
And then there are services that focus on specific capabilities. You've got Amazon Transcribe, which converts audio to text, Amazon Translate, which obviously does translations, Amazon Comprehend, which helps you understand the meaning and sentiment
Hmm.
in text, Amazon Lex, which is for building chatbots and virtual assistants,
Mm-hmm.
and Amazon Polly, which turns text into speech. So yeah, a whole bunch of tools.
So those are the tools. Now let's talk about how these models are actually created and used. What does that whole process look like? What's the ML development lifecycle?
Okay, so the ML development lifecycle is basically a series of steps that you go through to build and deploy an ML model.
Mm-hmm.
It starts with collecting the data you need from different sources. On AWS, you might use services like S3 for storing large data sets, Glue for preparing and transforming the data, or RDS if your data is in a relational database.
Right, so you got to gather all the ingredients first. Exactly. And then you move on to exploratory data analysis, or EDA, which is where you analyze and visualize the data.
Mm-hmm.
You're trying to understand its characteristics, find any patterns, and get some initial insights.
Okay.
For that, you could use tools like SageMaker Studio, or you could query the data directly in S3 with Athena.
Gotcha.
Once you have a good feel for the data, the next step is data pre-processing. This is where you clean and prepare the data, handle missing values, remove outliers, and scale the data appropriately.
Okay.
AWS Glue, SageMaker Data Wrangler, and SageMaker Processing can help with that.
Mm-hmm.
Then you move on to feature engineering. Here, you're basically creating or selecting the most important features from the data that the model will learn from. SageMaker Feature Store is a great tool for managing and reusing these features.
So it's like choosing the right ingredients to put into your recipe.
Precisely. Then comes the main event, model training. This is where you train your ML algorithm on the prepared data. You can use SageMaker or AWS Deep Learning AMIs, which are virtual machine images optimized for deep learning. And as part of the training process, you also need to do something called hyperparameter tuning.
Hyperparameter tuning, what is that?
Oh, that's where you fine-tune the settings of your model to get the best possible performance. SageMaker Automatic Model Tuning can automate that, which is super helpful because it can be a time-consuming process.
Sounds like it.
Once the model's trained, you need to see how well it's doing, right?
Right.
That's where model evaluation comes in.
Okay.
You test the model's performance on a separate data set that it hasn't seen before.
Okay.
Tools like SageMaker Debugger can help you spot and fix any problems, and SageMaker Model Monitor lets you track the model's performance over time.
Hmm.
If you're happy with how the model's performing, the next step is deployment.
Okay.
You deploy the model to a production environment where it can start making predictions on new data. You can use a managed API service like SageMaker Endpoint, where AWS takes care of all the infrastructure,
Mm.
or you can self-host the API on EC2 or EKS if you want more control.
Gotcha.
And even after deployment, you need to continuously monitor the model's performance using CloudWatch and SageMaker Model Monitor just to make sure it's still doing what it's supposed to be doing.
So you're constantly keeping an eye on it, making sure it's on track.
Exactly. You don't want it to go rogue.
Right. Now, where do these machine learning models come from? Do you always have to build them from scratch?
Not at all. You can use pre-trained models that are already out there. There are tons of open source models that have been developed and shared by the AI community, and those can be a great starting point, especially for common tasks. Or you can build your own custom models using your own data. That gives you more control and lets you tailor the model to your specific needs.
Right, so you have options. And you mentioned deploying models using managed APIs and self-hosted APIs.
Mm-hmm.
What are the key differences between those?
So with a managed API, like SageMaker Endpoint, AWS handles all the infrastructure for you, like scaling to handle traffic, making sure it's always available, and taking care of updates. It's very convenient.
Okay.
With a self-hosted API, you have more control over the infrastructure, but it also means you're responsible for managing everything yourself, which can be more work. So it's a trade-off between convenience and control.
Got it. This whole process seems pretty complex. How do you keep it all organized and running smoothly? That's where MLs comes in, right?
Exactly. MLOps, or machine learning operations, is basically like applying DevOps principles to the ML world.
Okay.
It's all about streamlining the development, deployment, and maintenance of ML systems so they're efficient, reliable, and can handle growth.
Mm-hmm.
So this involves things like keeping track of different versions and experiments, using tools like SageMaker experiments,
Right.
automating processes using SageMaker pipelines, and infrastructure as code tools.
Okay.
Making sure your systems can scale using EC2 and SageMaker's scaling features.
Gotcha.
Using version control with SageMaker Model Registry, implementing CI/CD pipelines, making sure everything is secure, and of course, monitoring your models and retraining them when necessary. So yeah, lots of moving parts.
It sounds like it. So how do you know if your ML efforts are actually successful? What metrics do you use to measure your progress?
So there are two types of metrics you want to look at.
Okay.
First, there are the technical model performance metrics. These tell you how well your model is performing from a technical standpoint, like how accurate its predictions are. Things like precision, recall, AUC, and F1 score.
Mm-hmm.
But just as importantly, you also need to track business metrics that show the real-world impact of your ML solutions.
Right. So you need to see if it's actually making a difference for the business.
Exactly. So you might track things like cost per user, development costs, customer satisfaction, and ultimately return on investment. These metrics tell you if your ML efforts are actually delivering value.
Okay. So we've covered a lot of ground on the fundamentals of AI and ML. Let's move on to this really exciting and rapidly evolving area of generative AI. What exactly is it all about?
So generative AI, as the name suggests, focuses on creating new content. It's about AI that can generate things like realistic images, videos, human quality text, or even audio, all based on the instructions or prompts you give it. So instead of just analyzing data, it's actually creating new data.
So it's like giving the AI a creative brief, and it goes off and creates something based on that brief.
Exactly. And there are a bunch of key concepts that make this possible. There are tokens, which are like the building blocks of text that the models process. Chunking is breaking down large chunks of data into smaller pieces that the model can handle. Embeddings and vectors are numerical representations of data that capture the meaning and relationships between different pieces of information. Imagine converting words and ideas into numbers that represent their meaning. We use special databases called vector databases for efficiently finding the most relevant information, especially for retrieval augmented generation, or RAG.
Vector databases.
Yeah. And AWS has a bunch of options for those, even building on services like Amazon Aurora to handle those vector searches.
Interesting.
Prompt engineering is about how to craft effective instructions for these generative AI models to make sure they produce what you want.
Okay.
And then, of course, there are the large language models, or LLMs, and the broader foundation models, which are the deep learning architectures that power all this generative magic. Multimodal models can process and generate different types of data, like text and images together. And diffusion models are a type of generative model that's been super successful at creating realistic images, videos, and audio.
Okay. That's a lot to unpack.
Yeah, it is a lot, but it's all pretty cool stuff.
Definitely. So what are some of the ways that businesses can actually use generative AI?
Oh, the possibilities are huge and constantly growing. We're already seeing it used for things like generating marketing copy, creating visual content, summarizing long documents, powering chatbots, doing language translation, and even generating code. Imagine customer service agents that can have more human-like conversations, search engines that give you summaries of results, and recommendation engines that come up with totally unexpected suggestions.
That sounds pretty transformative.
Yeah.
So how do you actually build and work with these foundation models for generative AI? Is there a specific life cycle involved?
Yeah, definitely. It starts with carefully choosing the data that you're going to train the model on. You need a massive and diverse data set to get good results.
Okay.
Then you select the right foundation model architecture for the task you're trying to accomplish. Then comes the pre-training phase, where the model learns general patterns from all that data. After that, you often do fine-tuning, where you train the model on a smaller, more focused data set to make it better at a specific task. Of course, you need to evaluate the model to make sure it's generating good quality content. Then you deploy the model so it can be used in applications. And finally, you gather feedback to keep improving the model.
So it's an iterative process, constantly improving. But generative AI sounds almost too good to be true. Are there any limitations or potential downsides that businesses should be aware of?
Absolutely. While it offers huge advantages in terms of flexibility and creativity, there are some limitations to keep in mind. One big one is something called hallucinations. This is where the AI generates output that's just plain wrong, nonsensical, or completely made up.
Okay, that sounds problematic.
Yeah, it can be. Another challenge is interpretability.
All right.
Sometimes it's really hard to understand why a generative model produced a particular output. So you can't always be sure how it arrived at its conclusion.
Mm-hmm.
And the accuracy of the generated content can be inconsistent, and sometimes you get different outputs even with the same input.
So you can't always rely on it to be perfectly accurate or predictable?
Right, so it's important to be aware of those limitations.
Definitely. So what factors should businesses consider when choosing a generative AI model for their needs?
Well, first, you need to be clear about what you're trying to achieve, what specific problem you're trying to solve.
Fact-
Then think about the level of performance you need in terms of speed, accuracy, and the quality of the output.
Right.
You also need to consider the capabilities of the different models, any constraints you might have, like budget or data privacy, and any regulatory requirements you need to meet.
Okay. And how do you measure the actual business value that generative AI brings? What metrics are important there?
Well, apart from the technical performance metrics, businesses are usually interested in things like how well the model performs across different tasks, efficiency gains, improvements in conversion rates, increase in revenue per user, the accuracy of the generated content, and the impact on overall business goals like customer lifetime value.
So you need to see how it's actually moving the needle on the business side.
Exactly.
Now, the exam guide highlights the AWS infrastructure and technologies for building generative AI applications. What are the key services we should know about?
Okay, so some of the main players here are Amazon SageMaker Jumpstart, which gives you pre-trained models and solutions to get started quickly. Then there's Amazon Bedrock, which provides access to a bunch of high-performing foundation models from different AI companies all through one API, so you can easily experiment and integrate different models.
Hmm.
Then there's this really cool tool called Party Rock, which is a web app built on Bedrock that lets you play around with different foundation models without any coding. It's a fun way to get a feel for things.
Okay.
And finally, there's Amazon Q, a generative AI-powered assistant that can help you with things like software development, writing, and answering questions.
So AWS is really providing a whole suite of tools for this. What are some of the advantages of using AWS for generative AI?
Oh, there are tons of benefits. For one, it makes these powerful technologies more accessible to more people and organizations, and it's more efficient and cost-effective because AWS manages a lot of the infrastructure for you.
Right.
You can also get to market faster because you're not building everything from scratch.
Makes sense.
And of course, you get the security, compliance, responsibility, and safety benefits of the AWS infrastructure. So it's a win-win.
Okay. And what about the cost side of things? Are there any specific cost considerations that we should keep in mind?
Yeah, definitely. You need to think about how responsive your application needs to be, the level of availability and redundancy you need, the performance of the different foundation models, and any regional requirements you might have.
Okay.
Pricing models can also vary.
Mm-hmm.
Many foundation models are priced based on the number of tokens processed, while some services have options for provisioned throughput or different pricing for custom models. So it's good to explore the different options and see what makes the most sense for your use case.
All right, so we have a good understanding of generative AI in general. Now let's get into the specifics of how these foundation models are used to solve problems. What are some of the key design considerations?
So when you're choosing a pre-trained foundation model for your application, there are a few things to consider. Cost is obviously a factor.
Right.
Then there's the type of data the model can handle, whether it's text, images, audio, or something else. That's called its modality.
Okay.
You also need to think about how quickly you need responses, which is called latency.
Hmm.
Does it support multiple languages if you need that? How big and complex is the model, which can affect cost and performance? Can you customize it to your needs?
Okay.
And what's the maximum length of input and output the model can handle? You also need to understand how different parameters like temperature, which controls how random the output is, can affect the model's behavior.
Okay, that's a lot to think about,
It is, but it's all important stuff to keep in mind.
definitely. The guide also talks about retrieval augmented generation, or RAG. What is that and why is it useful?
So R is a technique that's used to make LLMs more knowledgeable and accurate.
Okay.
Instead of just relying on the information the model was originally trained on, RI lets it pull in information from an external knowledge base when it's generating a response. This is super helpful if you need the model to have access to the most up-to-date information or specific knowledge that's internal to your organization. And the cool thing is you don't have to retrain the entire model.
So it's like giving the AI access to a library so it can look up information in real time.
Exactly.
That's really clever. What AWS services are typically used to store and retrieve that external knowledge for R?
Usually we store that knowledge as embeddings in vector databases, which are designed for this kind of similarity search. AWS offers a bunch of options like OpenSearch Service, Aurora with its PG vector extension, Neptune for graph-based knowledge, DocumentDB, and RDS for PostgreSQL, they can all store and query these embeddings really efficiently.
So it's like having a specialized search engine for meaning.
Exactly. It's searching for concepts, not just words.
That's cool.
Yeah.
So we've talked about customizing these foundation models. What are the different ways to do that, and how do they affect costs?
So there are a few main approaches. Pre-training, which means training a model from scratch on a massive data set, is the most expensive option. Fine-tuning is where you take a pre-trained model and train it further on a smaller, more specific data set. That's less expensive than pre-training.
Okay.
In-context learning is where you give the model examples and instructions directly in the prompt, which is very cheap but might not be as effective for complex tasks. And then there's RAG, which avoids retraining altogether but involves the cost of maintaining that external knowledge base.
Okay.
So the best approach depends on your needs and your budget.
Right. And finally, the guide mentions these things called agents.
Hmm?
What are those, and what role do they play?
So agents, like those available with Bedrock, allow these foundation models to perform more complex multi-step tasks. Imagine they're like little helpers that can interact with other systems and APIs. They can analyze a user's request, break it down into steps, call the necessary tools and functions, and then put it all together into a final response.
So they're like orchestrators, making sure everything gets done in the right order.
Exactly.
That's interesting. Now, let's shift gears and talk about prompt engineering. How can we get the best performance out of these models by crafting effective prompts?
Prompt engineering is all about giving the model the right instructions so it generates the output you want.
Yep.
Some key concepts to keep in mind are providing context, giving clear instructions, and even using negative prompts to say what you don't want. Understanding how the model organizes knowledge internally, its latent space, can also be helpful.
Latent space.
Think of it as a map of all the concepts the AI knows, where similar ideas are clustered together. If you understand this map, you can write prompts that guide the AI to the right area.
Okay, that's an interesting way to think about it.
Yeah. Some effective techniques include chain of thought prompting, which is like breaking down a complex question into smaller steps.
Rightly showing your work.
Exactly. And then there are different shot prompting techniques where you provide different numbers of examples to the model.
Okay.
Zero shot means no examples, single shot means one example, and few shot means a handful of examples.
Gotcha.
And you can use prompt templates to standardize your prompts and make things more efficient.
So what are the benefits of getting good at prompt engineering?
Oh, tons of benefits. First of all, you get better results from the model.
Okay.
It helps you experiment and discover what the model is really capable of. You can also use prompts to guide the model towards safer and more appropriate outputs, and it helps you uncover the model's knowledge and make sure your prompts are clear and concise.
It's like learning how to speak the AI's language.
Yeah, exactly.
Are there any risks or challenges with prompt engineering that we should be aware of?
Yeah, you do need to be careful. You don't want to accidentally expose sensitive information in your prompts. And there are things like prompt poisoning, where someone tries to manipulate the model with malicious prompts, and prompt hijacking, where they try to trick the model into doing something it shouldn't.
Okay, so security is definitely a consideration.
For sure.
Now, these foundation models are trained on huge amounts of data. How does that training process work?
So the initial training phase is called pre-training, and it involves feeding the model a massive amount of text or other data. This allows it to learn general patterns and relationships. After that, we often do fine-tuning, which is where you train the model further on a smaller, more specific data set to make it better at a particular task.
Right, so you're specializing it.
Exactly. And continuous pre-training is about training the model even further after the initial pre-training. Some common fine-tuning methods include instruction tuning, domain adaptation, transfer learning, and continuous pre-training.
Okay, that makes sense.
Okay.
What about the data used for fine-tuning? What should we keep in mind about that?
Data quality is super important. You need to make sure the data is accurate, relevant, and representative of the real-world scenarios you'll be using the model for.
Okay.
You also need to think about data governance, the size of the data set, whether it needs to be labeled, and if you're using techniques like RLHF, which stands for reinforcement learning from human feedback, you'll need to get human evaluations of the model's output to make sure it's aligned with human preferences.
So it's not just about feeding the model data. It's about feeding it the right data.
Exactly.
Now, once you've trained or fine-tuned your model, how do you evaluate its performance?
Evaluating generative AI models often involves a combination of human evaluation and using benchmark data sets.
Okay.
Human evaluation is where people actually look at the generated content and assess its quality, coherence, and relevance. Benchmark datasets are collections of data with known correct answers so you can compare the model's output.
Hmm.
There are specific metrics for evaluating generated text like Rouge, BLAU, and BERT score. But ultimately, the most important thing is whether the model is helping you achieve your business goals.
Right, you need to see if it's actually making a difference.
Exactly.
All right, we've covered a lot about building and using these models. Now let's talk about responsible AI. What does it mean to develop AI responsibly?
Developing AI responsibly means taking into account the ethical implications and striving to create positive social outcomes. It's about thinking about the potential harms and focusing on things like fairness, inclusivity, robustness, safety, and truthfulness.
So it's not just about what AI can do, it's about how it's used.
Exactly.
Are there specific features or tools that can help us identify potential issues?
Yeah, there are.